All right, let us start talking about lists. Now, we've already encountered lists in our exercises. For example, when we created this paneled surface. So I'm going to start by just displaying the selected objects. So we have this curve and we divide it. And so we put one curve in, and on the other side we get this list of points. So let's look at them with a panel. You can see now that we have, because we're dividing it into 8 segments, we get 9 points. And each of these points, of course, has got an X, a Y, and a Z coordinate. And this list has got indices. So the number here at the beginning is not part of the coordinate. It's simply where that coordinate comes in the list. So the first item of a list will always have the index of 0 because the counting for the index starts at 0 in Grasshopper. So it goes 0, 1, 2, 3. And if we have 9 elements in our list, the largest index will be 8. And you can already see that we're dealing with a list as an output because the line which connects the blocks here looks different. See, if we have a single curve, we get a solid line. If we have a list of coordinates, for example, we get this double line. And you can see this as we continue. So we take these points and turn them into a polyline. So we've got a double line going in and a single line going out because what's coming out is a single polyline curve. All right? And then we explode it again, so we go in with the single polyline, and out comes a list of line-like curves. And when we then extrude them, we get another list of untrimmed surfaces. And now when we do our linear array, what happens is that we are going to get, hang on, I'm going to put up another panel. Here we go. We get this list of lists, right? So previously we had these 8 untrimmed surfaces, and now for each of these 8 untrimmed surfaces, we've created a linear array of 4. So what we've got is a list of lists, kind of. And in Grasshopper, this is called a tree. So what's happened is that out of these 7 list items, we've created 7 branches of a tree, and then each of these branches has got a list attached to the end with 4 entries. And you can see this tree if you take the Param Viewer tool. You can see it says, okay, I've got 8 branches, and each of these has got 4 entries in its final list. And if you go right-click, draw tree, you see why they talk about a tree here. But all this tree stuff is something we're going to be getting into later during the course. For now, it's just so that you know why this looks different from this and why sometimes you get these lines which are dashed instead of simply double. That means it's a tree. Okay, so I'm going to hide all of this and we're going to talk a little bit about generating lists. Here we go, hide it. Let's go down here. Now, I'm just going to cover a few ways of generating a list. These are not all the ways to generate a list, and you can see a lot more options for generating lists here, for example, in the sequence panel. So what I'm going to start with is the range. Now the range takes a domain, so a start and an end, and then a number of steps. So if we put a panel on the other side, you can see the default ranges from 0 to 1, and we've got 10 steps. Right? So the step is the distance between every single item. So because we've got 10 steps, we end up with 11 values. Right? That's something to keep in mind. And I'm going to add a slider here to change the number of steps. So you can see as we change the number of steps, that same domain from 0 to 1 gets divided into the according number of steps. So if you've only got 1 step, it goes 0 to 1. Now, the next question you'll probably have is, well, how do you change the start and the end? For that, we have to construct a domain. And for that, you go to the Math tab, and you can see this domain section, and we can go construct domain. And all the domain wants is, where do I start and where do I end? So if we take 2 more sliders, and let's go to 4. There we go. Put that in there, domain start, domain end, and then plug this domain into here. You can see that now we're taking 5 steps between 2 and 4. And we can change this any way we like. You can even go and have the end be lower than the start. So now, instead of going from 1 to 9, we're going from 9 to 1. Right? So the direction doesn't matter. Now let's compare this to another command for generating this. Actually, just let me maximize the Grasshopper here and get a little bit more space. Okay, so let's compare that with the series command. Now series, unlike the range commands, actually has got 3 inputs. Right? So I'm going to, let's start here. We've got, and what it takes is, it takes a start, and step size, and then a number of values in the series. Right? So let's start it at 0, and then say that each step is supposed to be 3 wide, and that we want to have 5 entries. Then what we get out on the other end is exactly 5 values, because we set a count of 5, and each of these values will be 3 away from the previous value. Right? So if we increase the step size, the final, the highest number, the last number, will grow. So here we've divided a domain. We've divided something between a start and an end. And here we just give it a start, and then how big the steps are and how many steps it's supposed to take. These are 2 of the most basic and probably most often used ways of creating a series or a range of numbers, of course. There is a third way, and that is simply to type it manually. If you simply do a panel, double click into it, and then start writing values. So 2, and then we're going to have a 35 maybe, and a 7.8, and then a 42. We can create our lists arbitrarily by hand. Right? Problem is, this doesn't look the same way as that, and actually this will be interpreted as 2 carriage return, 35 carriage return, 7.8 carriage return, and then 42. So to get a list of these values, we have to go right click and then deselect multi-line data, and then we've got a list which we can use for whatever purpose we intend. Right? So that's just 3 useful ways for creating lists. There's a lot of other ways to create one. You can create random lists, and you can create sequences, you can repeat things, and we'll probably run into a few of those during later videos. But for now, I would like to show you 2 commands which are very important, namely obtaining information from a list. So if you've got a list, how do we get at the data inside that list? And one thing that's very important usually is to be able to determine the list length. So how long is that list? And this could, for example, be useful if you've got a list of, for example, line segments, or you've got a list of floors or something, and you need to generate some form of geometry which has got the same amount of entries, or maybe half the amount of those entries. Then, of course, if you want to create it fully parametric, you would have to determine how many items have I got and how many items do I have to create now. And for that, you can use this length command. So if we plug it in here, you can see 6 entries, the length is 6. straightforward. So how do we now get at the data inside of these lists? Well, we use the index. And for that, I would actually like to show you an example. Say we have a surface, and a command you're already familiar with is the deconstruct brep, right? So if we've got a geometry, or in this case, a brep, now let's go set one geometry, here we go. Let's hide this, visibility, hide objects, there we go. So we've got this, actually let's also hide that line. There we go. So if we plug this geometry into the deconstruct brep command, we get three things out on the other side. So I'm going to use another geometry param block and then hide these two so that we can look at them individually. So the first one is the face, so the actual surface. And the next thing is the edges, and then you've got the vertices, so the four corners here. And let's say we want to use these edges and divide them to create a division of the surface, or we want to have the corners to create some form of other geometry from this. Maybe we only need two of the edges or a single edge. Well, what we're getting here, of course, is a list, right? You can see we've got 4 curves here. And to get at those individual curves, what we can use is the list item block. So we plug a list in and then give it an index, and out comes that item from the list. So let's do this here. So right now, by default, that item index is 0. So I'm going to put a slider here, and there we go. And now we can actually go through those 4 curves. So I can go 0, that's the second one, so index 1, index 2, index 3, and actually I can go to index 4 even though this doesn't have an index 4. Go to 5, 6, 7, 8, 9, 10. And the reason I can do that is because the wrap is set to true. So once it reaches this, it starts at the beginning again. So if we'll use a toggle to change that value. So now it's false, and you can see that for these first 4 indices, I actually get a result, and as soon as I go beyond that, this will give me a warning saying supplied index is too high. All right? Now, this list item block has got a very useful feature. If you zoom in on it, these plus icons will appear. And if you click on them, what you can actually do is, if you just leave this at the default value of 0, we can actually just get index 0, 1, 2, 3. And that makes it very, very easy to then access the individual things. So you don't actually have to copy paste this block. You just create one, zoom in, hit plus a few times, and there you go. And so now we could say, okay, I want to have the top and the bottom curve. So I'm going to use index 0 and index 2. And I'm going to use shift to put both of these in the final geometry block, hide this, and now I've got those two. Or I could take these two, right? Or do the same thing with the vertices. And now I could take that and go line. Here we go. And create one line between those 2 points. Let's delete this. And create a second line between the other 2. There we go. Diagonal cross bracing. Done. Right? So that's how you can get at the different items in a list. I've also shown you how to determine the length of a list, how to create a range, a series, and how to manually create lists. Thank you for watching.